Now let us look at question number 6. Now it says in a model ship the mast is 9 centimeters high while the mast of actual ship is 12 meters high. If the length of the ship is 28 meters, how long is the model ship? So the first step is to see whether any kind of relationship exists and whether it is a direct relationship or not. So we find that I am trying to draw the ship here. So this is the length of the ship, and what are masts? Masts are, if you would have seen in movies and other things, these are these huge poles which are placed on top of the ship, and they have these flags, and they take the ship in the forward direction. So this is how the ship looks like, length of the ship and length of the mast. Now if you have to create a model of the actual ship, the actual ship the model is also based on the dimensions of actual ship, yes or no? So as the dimensions will increase in the model ship, the same in the actual ship, the dimensions will also increase in the model ship, yes or no? As the dimensions, as the length increase in the actual ship, in the model ship also it will increase. As the length of the mast will increase in the actual ship, in the model ship also it will increase. So we can say that it is a case of direct proportion. Now we all know from here that the first step will be to tabulate. So we say that model dimensions of model ship and dimensions of actual ship. Okay. Just I will put it in the form of a table. So can we say that in the model ship the mast is 9 centimeters, in the actual ship it is 12 centimeters. If the length of the ship is 28 meters, so the actual ship, the length is 28 meters, we have to find out length of the model ship. So we say let A be the length of model ship. So if A is the length of model ship, we know that x1 by y1 equals to x2 by y2, which means that 9 by 12 equals to A by 28. Now you just have to simplify this. A equals to 9 into 28 by 12. So 9, so 21. Length is 21 meters. If this is clear to everybody, can we move to the next problem? Now let us move to question number 7. It says suppose 2 kg of sugar contains 9 into 10 to power 6 crystals. How many sugar crystals are there in 5 kg of sugar and 1.2 kg of sugar? Now we all know sugar is made up of sugar crystals, and as the quantity of sugar will increase, the quantity of sugar crystals will also increase. Therefore, it is a clear case of direct proportion. So we will just get going quickly. We will just say that quantity of sugar and number of crystals. Put it in a table and just put values here. It says 2 kgs of sugar have 9 into 10 to the power 6 crystals, how many are there in 5 kgs of sugar. So, you let this be 5, let this be A, let A be the required number of crystals, right. And since it is a case of direct proportion, x1 by y1 equals to x2 by y2. This implies that 2 by 9 into 10 to the power 6 equals to 5 by A. This means A equals to 5 into A goes here 9 into 10 to the power 6 by 2. So, 9 5s are 45 into 10 to the power 6 divided by 2. This becomes 22.5 into 10 to the power 6. Can I write it like this? And if I have to shift the decimal point to the left hand side and write it in the standard form, what I will do? I will multiply it by 10. So, this will be 2.25 into 10 to the power 7. This is the first part. In the second part, it says how many crystals of sugar are there in 1.2 kgs of sugar. So, again quantity of sugar will change to 1.2. Rest everything else remains same. The same calculations you will have to do. You just write 1.2 here. Therefore, A is 1.2 divided by 2 into 9 into 10 to the power 6. This is 0.6 into 9 into 10 to the power 6, 9 6 are 54. So, you get 5.4 into 10 to the power 6. So, there are 5.4 into 10 to the power 6 crystals in 1.2 kgs of sugar, right. Is it clear? Now, we move on to the next question. Now, let us have a look at question number 8. It says Rashmi has a road map with a scale of 1 centimeter representing 18 kilometers. She drives on the road for 72 kilometers. What would be the distance covered on the map? Now, earlier people used to use physical maps. Nowadays, we all use Google Maps. Now, Google Maps are used to tell you distance from one place to another, direction from one place to another. But one thing which remains constant is the more is the distance which you travel on Google Map, the more is the distance which you will travel on ground, right. The larger is the distance that you go from point A to B on the map, the more is the distance that you will go on the ground. So, this is a case of direct proportion. Now, once this is done, we all know that we have to make a table. So, distance on map in centimeter and distance on road in kilometers. So, 1 here is 18 kilometers on ground. Therefore, if you travel for 72 kilometers on the ground, how much will it be on the map? So, you say let A be the required distance on map. And since it's a case of direct proportion, we can say x1 by y1 equals to x2 by y2. Now we just substitute the values. 1 by 18 equals to a by 72. Therefore, a equals to 72 by 18, that is equal to 4 centimeters. Therefore, distance covered on map equals to 4 centimeters. Right? Shall we move on to the next question? Let us see question number 9. It says a 5 meter 60 centimeter vertical pole casts a shadow 3 meters 20 centimeters long. Find at the same time, there are two parts to it. First part, length of shadow cast by another pole 10 meters 50 centimeters high and height of the pole that casts a shadow 5 meters long. Now we all know higher the length of the more the length of the pole, the greater is the length of the shadow. Right. So since it's a case of direct proportion, we will make a table. Right. So it says height of pole and length of shadow. Now a 5 meter 60 centimeter pole casts a shadow of this long. Now this is a combination of meter and centimeters. So can I write 5 meters 60 centimeters as 5.60 meters? Yes or no? We know 1 meter equals to 100 centimeters. 1 meter equals to 100 centimeters. So how much will 60 centimeter be? 60 centimeter is equal to 0.6 meters. Since 100 centimeter equals to 1 meter, 60 centimeter is equal to 0.6 meters. So I can write this as 5.6 meters. Right? Similarly, I can write 3 meters 20 centimeters as 3.2 meters. So we will attempt the first part. What is the length of the shadow cast by another pole 10 meters 50 centimeters high? So height is 10.5 meters. We have to find the length of the shadow. x1 upon y1 equals to x2 upon y2, since it is a case of direct proportion. Therefore 5.6 upon 3.2 equals to 10.5 by a. What do? You say a equals to 10.5 into 3.2 divided by 5.6. We know 8 4s are 32, 8 7s are 56. Right? And here you divide 1. So you can just, so what do you get? A equals to 10.5 into 3.2 divided by 5.6. So you can just remove the point. 8 4s are 32, 8 7s are 56, 1.4 into 4, that is 6 meters. So a pole of height 10.5 meters will cast a shadow of length 6 meters. So length of shadow is equal to 6 meters, right? Is this clear? The point to be noted here is that since it's given as a combination of meters and centimeters, you have to either convert it into meters or convert it into centimeters. So the unit has to be made, either it can be 5 meters 60 centimeters, you can write it as 560 centimeters and then do it, right? Can you do it like that? You can do it as, you can convert everything into centimeters and do it, or you can convert it into meters and do it. So you have to ensure that the unit remains the same, and that is how you have to proceed. In either case, the answer will be the same, right? The second part is, what is the height of the pole which casts a shadow 5 meters long? Now shadow is given to us as 5 meters and we have to find the height of the pole. So let A be the height of the pole. So you get x1 by y1 equals to x2 by y2. This implies 5.6 by 3.2 equals to A by 5. So you get A as 5 into 5.6 divided by 3.2. 8 7s are 56, 8 4s are 32. So you get 35 by 4. What do you get this? 8 4s are 32, 8.25 meters. So the height of the pole is 8.25 meters. Is this clear? Can we move to the next problem? Again, like I like to mention, you should not forget that the units have to be either converted into meters or they can be converted into centimeters, but whatever method you adopt, the answer will come out to be the same, right? So we will move to the last problem, the 10th problem of direct. Okay, now we come to the last problem of exercise 13.1. It says a loaded truck travels 14 kilometers in 25 minutes. If the speed remains the same, how far can it travel in 5 hours? Now clearly, if the speed remains the same, as the distance will increase, what will happen to the time taken? That will also increase, right? So it is a case of direct proportion. So now we are very clear how we have to solve such problems. We will just tabulate it. Now it says distance in kilometers and time. Now you will find that there are two different units of time which are given here. One unit is in minutes and the other is in hours, right? So here, when the same quantity is given to you in two different units, then you have to ensure that you convert the two units or two quantities to in the same unit. So either we make hours into minutes or minutes into hours, right? So what do we do here? We say we have been given that it travels 14 kilometers in 25 minutes. So, let me take time in minutes. If the speed remains the same, how far it can travel in 5 hours? Now, we have been given 5 hours. Now, I will convert hours into minutes, and we know that 1 hour is equal to 60 minutes. Therefore, 5 hours is equal to 5 into 60, that is 300 minutes, right. So, we put 300 here. So, now the time, I have got the time in the same unit, yes or no? I have got the time in the same unit. Now, this distance requires to be calculated. So, we say let the required distance be A, and since it is a case of direct proportion, we all know very clearly now that this will hold true. So, just substitute the values, you get 14 by 25 equals to A by 300. We know how to solve this equation. We will get A as 14 into 300 by 25, right. So, we know 5 5s are 25, 5 6 are 30, and what do you know? You know that, right, you know, 5 into 12. So, what do you get here? You get as 168, right. So, if the speed remains the same, the required distance is 168 kilometer. With this, we come to the end of direct proportion and the exercise 13.1. In the next session, I will be talking about inverse proportions. We will understand the concept and take up some questions from the book. If you have liked watching my video, please press the like button. If you would like to hear more from me and see more of these videos, please subscribe to my channel Math Cube and press the bell icon for notifications. Thank you.